Hello students, I am Professor Isha Medirata from LG Institute of Engineering and Technology. So till now, we have completed 4 chapters from our syllabus, and today I will be starting with the 5th, that is last chapter of our syllabus, that is light semiconductor interaction. Weightage of this chapter according to GTU syllabus is 17%. We are going to study Einstein's theory, semiconductor laser, what exactly is the principle of laser and some important terminology. Then we are going to study what is photovoltaic effect. Based on that, what is solar cell, its applications, then Drude model, Fermi's golden rule. We have a concept called joint density of states and exciton. So all these topics will be covered in this chapter. In today's video, I will be starting with Einstein's theory and semiconductor laser. So I will be briefing you what exactly is the principle on which laser works, and we are going to discuss a gallium arsenide laser. So let's start with Einstein's theory first. According to Einstein, he believed that whenever there is an interaction of radiation and matter, let us consider a small atom. Anything that occupies space here is called matter. So whenever radiation we mean light. So whenever there is an interaction between light and atom, there are likely 3 processes which can occur. Let's see what are these 3 processes. The first one is induced absorption. What do you mean by the word absorption? It means an atom is absorbing that radiation. So the matter is absorbing the radiation and it is getting excited. The second process is known as spontaneous emission. Emission means the matter already has energy and it radiates or emits that energy. What do you mean by the word spontaneous? Spontaneous means suddenly, on its own. Third process which is likely to occur is stimulated emission. Stimulate, what do you mean by the word stimulate? Stimulate is with the help of something. So it is with the help of external energy that the emission takes place. So let's start with these processes in detail. Before that, let us assume the following parameters on which I will be explaining these 3 processes. The first parameter we assume is E1, that is the lower energy. It is known as the lower energy level. Then we consider E2 as the higher energy level. Then we are considering only one atom to explain the processes. And lastly, we are considering E2 minus E1 is equals to h nu. What is h nu according to Planck's theory? H nu is the energy of a photon. So the difference between the 2 energy levels is equals to h nu, and that is nothing but the photon which is emitted. The energy of the photon which is emitted. So these are the following parameters which we are considering to explain the 3 processes. So let's start with the first process, that is known as induced absorption. What do you mean by the word induced absorption? Induced means it is with the help of some external source, and absorption means the matter is taking the energy from the radiation. Let's see what induced absorption is. So it says if a photon is incident on an atom which is in lower energy state, the atom absorbs the energy and it gets excited to a higher energy state. This process is known as induced absorption. So for induced absorption, I can say that the atom has to be in the lower energy level, because if the atom is not having energy, only then it can absorb energy and excite to a high level. So let's see what exactly this process is. So here in this diagram, I have shown E1 as the lower energy level, E2 as the higher energy level, and we have only one atom in the process. This atom will stay in the lower energy level till external energy is provided. Without any external energy, the atom cannot excite to a higher level. So this is the situation which is before absorption. Now let's see what happens if light is incident on it. So if there is a light incident on this atom, that is h nu, which should be exactly equal to or more than the difference between E2 and E1. So what happens if this light is incident? This atom is moving on to the higher energy level E2. That means the atom has taken the energy h nu and it has excited to the higher energy state. Here I can say atom plus a photon. There was only an atom. a photon was incident and the atom becomes an excited atom, which is denoted by atom star, which means it is now in the higher energy level. I can say that rate of absorption. Now in this process I only have one atom. If there were 100 atoms would have moved to higher energy level by absorbing radiation. So we can say that the rate of induced absorption, it is denoted as R12. Rate of 1 to 2 means the transition from 1 to the energy level 2. So R12 is proportional to N1 into rho. What do you mean by the word N1? N1 means the population of lower energy level. What do you mean by the term population? The number of atoms which are present in the lower energy level. So rate of induced absorption depends upon the number of atoms and it also depends upon the density of radiation rho. If I remove the proportionality sign in the equation, I can define a proportionality constant as R12 is equals to B12 N1 rho. Here B12 is known as Einstein's first coefficient and it is known as the probability of induced absorption per unit time. Now let us move on to the second process that is known as spontaneous emission. Spontaneous emission is a process in which there is emission of a photon when an atom transits from a higher energy level to a lower energy level without help from external source. This is what is spontaneous emission. So without any external help, the atom which was already in the higher energy level is now moving on to the lower energy level. As we all know that energy can never be destroyed, so what happens to the energy difference? Because higher energy to lower energy, so that energy is released in the form of a photon. Let's see the process in detail. So again we have two different energy levels, E2, E1, and the atom is in the excited state or the higher energy state. Let's see what happens after emission. So what happens to this atom? This atom will move down. It has come to the lower energy level after emission and in turn it has released a photon. So I can say atom star is equals to atom plus a photon. What does that mean? Excited atom is now coming to the lower energy state releasing a photon. I can define the rate of spontaneous emission as R21 spontaneous. So instead of spontaneous we denote SP and that depends upon N2 only. It only depends on how many atoms are present in the higher energy level. If one atom is present, one will come down releasing a photon. If 100 atoms are present, 100 will come down releasing 100 photons. And so we are defining a proportionality constant A to 1, which means from 2 to 1. And this is known as the probability of spontaneous emission per unit time. Now let us move on to the third and the last process defined by Einstein, which is known as stimulated emission. So this is a process in which there is an emission of a photon when an atom transits from a higher energy level to a lower energy level with the help from external energy. So it is actually taking help from external energy and then the emission process is taking place. Let's see how this happens. So this is the situation which is before emission. The atom is in the excited state. Now let's see what happens next. If there is a photon which is being incident, the atom is absorbing the photon, it is coming down and instead of one we are getting two photons. You can see from the diagram that two photons are emitted having the energy difference h nu. This means I can say the equation as excited atom by absorbing energy is giving us atom plus a photon plus a photon. One of them is the inducing photon and one of them is the resultant photon. And so I define the rate of stimulated emission. Now this rate also depends on the photons being absorbed. And so in the equation we have R21 stimulated is proportional to N2 into rho. It depends on how many atoms are present in the higher state as well as the density of radiation. And so the third coefficient of Einstein is defined as B21, which is known as the probability of stimulated emission per unit time. So this was about the three processes which Einstein discussed. Let's move ahead. Of the three processes discussed, we can say that stimulated emission process is required for the generation of laser. Now let me just brief you what laser is. Laser is known as light amplification by stimulated emission of radiation. So for laser action, we require stimulated emission. Only stimulated emission will give us coherent beam. What do you mean by coherent beam? All the photons of laser travel in one straight line. Unlike the normal light source spreads, but laser acts as a highly coherent or a parallel beam. So of these three processes, if I say I have more number of atoms in the lower energy level and I incident energy, what will happen? Which process will occur? It is induced absorption which is likely to occur because all the atoms are in the lower energy level. They are going to absorb the energy and they are going to move to the higher energy level. So that is not going to give us stimulated emission. So for stimulated emission, what do we require? We require that more atoms should be present in the higher energy level, because only then, if the radiation is incident, these atoms will come down, giving us a coherent beam. So we say that to achieve laser action, we should increase the rate of stimulated emission. So now I'm going to start with the basic terms which are related to laser. Starting with the first one, I have population inversion. What does this mean? Just now I said that we should increase stimulated emission if we want to achieve laser. That means we should have more number of atoms in the higher state as compared to lower state. How will these atoms go to the higher state? If you provide external energy. So what is population inversion? It is the state of achieving more number of atoms in higher energy level compared to lower energy level. That means we have the condition N2, means population of higher energy state should be greater than N1, that is the population of lower energy state. Now how is this population inversion achieved? It is achieved by a term called pumping. Pumping means to supply energy. So mechanism of exciting atoms from a lower energy level to a higher energy level by supplying some energy from external source. We call this process as pumping. Next term we are going to discuss is lasing. Lasing means just the process where stimulated emission starts. So it is the process which leads to the emission of stimulated photons after achieving population inversion. How is population inversion achieved? With the help of pumping. And then when stimulated emission starts, we say the process is lasing. Lifetime. The maximum time period for which an atom is in the excited state is known as lifetime. Now this particular definition, you can say an atom stays in the excited state for a very less duration, because higher the energy, higher is the instability. So this lifetime is around nanoseconds. Let's discuss the next one, which says metastable state. Now, if I say my atom is having 100% energy, it cannot absorb more energy, so you can never have stimulated emission. So, stimulated emission starts at a level which is comparatively having lower energy as compared to excited state. And if I say energy is comparatively less, my atom will be more stable. So, I say the energy level in the atomic system where the lifetime of atom is large. Because if the lifetime is large, it will stay there for a longer period and only then stimulated emission can be achieved. And this duration is around milliseconds. Let us discuss the next term, that is active medium. It is the medium where population inversion is achieved for laser action. Moving on to the next one, we have optical resonator. The full form of laser has a term called amplification. So how is that laser beam amplified? It is amplified with the help of an optical resonator, which is a pair of reflecting surfaces, of which one of them is a perfect reflector and the other is a partial reflector. Perfect reflector means it will reflect 100% light, and partial reflector means some of the light will be transmitted as well. Let us discuss what optical resonator is. In the diagram, you can clearly see that we have a high reflection mirror, which is indicated by dark blue, and by light blue we have a partial reflecting mirror. In between them, red colored shows the active medium, the green colored shows the pumping source. So with the help of pumping source, population inversion is achieved and stimulated emission is taking place. What happens to those emitted photons? The photons which strike on the full reflecting mirror will not be emitted. They will come back and excite more photons. And this chain reaction will increase or amplify the laser beam. So this is what optical resonator is. Now let's see what is the basic principle of laser before I start semiconductor laser. So first point is you require an active medium without which population inversion is not possible. Then you have a pumping source which is required for population inversion. Then you have optical resonator which is required for amplification. Only then your laser beam will be amplified, and this is what gives us a highly intense laser beam. So these are the basic steps for generation of laser. So with this, I start with the semiconductor laser, which is also known as the injection laser diode. So let's start with semiconductor laser. What is a semiconductor laser? It is a specially fabricated PN junction diode which emits laser when it is forward biased. So it is basically a PN junction diode only which is emitting laser beam when it is forward biased. Basic principle of semiconductor laser is electroluminescence by absorbing electric current, emission of light. So the principle is electroluminescence. Let's see the working principle of laser. So when a PN junction diode is forward biased, what happens in forward bias of a PN junction? The electrons from N region move to P region where they recombine with the holes. So now we know that energy level of the conduction energy level is more than the valence energy level, and the holes are in the valence band. So from the conduction, these electrons come to the valence of P type and recombine with the holes, and so they release energy in the form of photons, and this is what is the working principle of laser. During this recombination, energy is released in the form of photons. Let's see how. So we have EC to EV. This electron is coming down, releasing energy, and the base shows the recombination process. So one electron releases one photon, and this exactly is how radiative recombination takes place. Now let's see basically how a semiconductor laser works. So first requirement is forward bias of a PN junction diode. Now this gives recombination of electrons and holes which releases photons. Now these photons, they stimulate more electrons, that means they are amplified, and this is how the laser beam is generated. Now let us discuss the construction of a semiconductor laser. A semiconductor laser has it is a PN junction diode. So here we are discussing GaAs, that is gallium arsenide laser. So it has a P type, that is gallium arsenide. It has an N type, that is again gallium arsenide. So if I say gallium arsenide as a P type, means it is biased, it is doped with a trivalent impurity, and if the negative is considered, it is doped with a pentavalent impurity. In between them you can see the red colored junction which is known as the depletion layer, and here we call this as the active region. Now because they are semiconductors, what is done on the top of anode, that is P type, and on the bottom of cathode, that is N type, a layer of metal is done, and the metal contacts are taken out from there. Metal is generally polished. The polishing is done using metal to increase the conductivity. On one side you can see there is a perfect reflector where you can see only residual light, only a part, and the laser beam is emitted from the part where there is a partial reflecting mirror. So this is the basic construction of a laser. Let us understand the working, which is population inversion is achieved by applying forward bias. So it's a diode. On applying forward bias, it will achieve population inversion because photons will be released, and because of the forward bias applied, more atoms will get excited. Then you have recombination of electrons and holes results in the emission of photons. Now this is a spontaneous emission. This spontaneously released photons, they trigger stimulated emission. How? They excite more and more electrons and send them to higher energy level, and thus increasing stimulated emission. If the current density is increased, the emission becomes more and more coherent, and the radiation intensity also increases. And now we have the wavelength of this emitted radiation depends upon the concentration of donor and acceptor atoms added and the energy band gap of semiconductors. Let's see how. So we know that Eg is equals to h nu, E is equals to h nu, or I can write hc by lambda. Here h is the Planck constant, c is the speed of light, and lambda is the wavelength of radiation. Now we know that for GaAs the band gap is 1.44 electron volt. So substituting 1.44 electron volt in the above equation, we get the value of lambda as 8628 angstrom, that is 8628 angstrom, which is the wavelength of the emitted radiation. The photons which are emitted will be having this wavelength. Then we have advantage. Starting with the first advantage, the modulation of output is controlled by the junction current. You can control the output by controlling the junction current. Next we have, it is small, compact and has a higher efficiency. The entire setup is comparatively small and compact, having a higher efficiency because direct modulation of output is achieved with the help of current, the junction current. Then we have fabrication is simple and the output is continuous. Till you are giving the forward bias continuously, you will be getting the output. Lastly, we have, it has a low power consumption and it is less costly. Moving on to the disadvantages, we have output is in the form of a highly diverged beam. You need to convert it into a highly convergent beam. Threshold current density is large. Then we have monochromaticity and coherence is less as compared to the other types of lasers. And that is the reason this type of laser does not have many applications. Then we have temperature affects the output of laser because it uses semiconductor and semiconductor is affected by temperature. Temperature is going to affect the output of this laser. Coming on to the applications of semiconductor laser, we have it is used in long haul communications, that is long distance communications. Then we have it is used in optical communications like computers, mobile phones, etc. Then it is used in laser printers. It is used in laser microscopes and line lasers. Line lasers are an application in defense. So today we have discussed what is Einstein's theory, what are the three processes related to Einstein's theory. We have discussed the principle of laser. We have discussed what a semiconductor laser is, its advantages, disadvantages and some of the applications. Hope you have understood all the topics I explained today very well. I will be starting with the next topic, that is joint density of states, in my coming video. Till then, take care. Thank you.